This is HIM2214 Health Statistics, taken from the textbook Basic Allied Health Statistics and Analysis, 3rd edition. This presentation is over Chapter 3, Mathematical Review. Presentation objectives. After studying this chapter, the learner should be able to understand the terms fraction, decimal, percentage, rate, ratio, and proportion. Distinguish between the numerator and denominator of a fraction. Average a set of numbers. Round data to a specified number. Convert a number from one form to another form, fraction to percentage, ratio to percentage, decimal to percentage, percentage to decimal, and percentage to fraction. Data is compiled and organized in meaningful ways in all types of healthcare settings. We can convert data into usable information by using mathematical and statistical formulas. There are a number of basic mathematical functions that the HIM professional needs to be able to master, and we're going to cover a couple of them in this presentation. The first one we're going to look at is fractions. Fractions are a part of a whole. You have a numerator and a denominator, which is one way in which we can express a fraction. If you have a fraction and you want to increase the value of the fraction, you can either increase the numerator, or you can decrease the denominator. So, for example, in that fraction 6/7, if I wanted to increase the value of that fraction, then I can increase my numerator, which is the number 6, and maybe instead of 6/7, I can say 12/7. Or I can increase the value of the fraction by decreasing the denominator. So instead of 6/7, I can have 6/3. Okay, so that's one way. That's two ways we can increase the value of a fraction. Now, on the other hand, if I want to decrease the value of the fraction, I can decrease my numerator, or I can increase my denominator. So it's just the opposite. So in other words, when I look at the fraction 6/7, and I want to decrease the value of the fraction, I said I can take my numerator and decrease it. Therefore, I can do, instead of 6/7, I can do 3/7, and that's decreasing the value. Or increase the denominator. So instead of 6/7, 6/14. Now, you can take that fraction, and if you actually go ahead and divide 6 divided by 7, then the number that results from me dividing that fraction we call the quotient. Now, I can also reduce a fraction. When you reduce a fraction, this means you will put this fraction in a simpler form, or you're going to reduce the fraction to its lowest form, or lowest term. This does not change the value of the fraction. When I reduce a fraction, I'm not changing the value of the fraction. You can reduce the fraction by finding a common number to divide both the numerator and the denominator, thus deriving a simpler fraction. You can do this with all numbers except for 0. So let's look at an example here. I can take the fraction 5/10 and reduce that fraction by dividing the numerator and the denominator by 5. So if I divide 5 by 5, I get 1. If I divide 10 by 5, I get 2. Therefore, I'll have 5 over 10 reduced is 1/2. Okay? So that's how you reduce a fraction. Now, another mathematical concept is that of the decimal. Decimals are also fractional values. They are an amount that's less than 1. Okay? Some examples of a fraction is 0.8, 0.08, or 0.008. And really it is a decimal is a fraction based on divisions that are power to the negative base of 10. That's how your book writes it. In other words, these are place values. So that 0.8 is in the 10th place, so that's 8 over 10. Or 0.08 is the 8 is in the 100th place, and then in 0.008 the 8 is in the 1000th place. So it's based on a negative base 10. All right, so that's your decimals, amounts less than 1. Percentages, when we're looking at a percentage considers how many times something happens out of 100 times. It is a proportion of a whole. So your book gives you an example of a percentage. If we say 40 out of every 100 hospital employees have attained a 4-year college degree, then we can say that 40% of those employees have earned a bachelor's degree. All right? So that was 40 out of 100, or 40%. That's a proportion of the whole. Now you can also convert different values to another form. In other words, I can go from a fraction to a percentage, from a decimal to a percentage, from a percentage to a decimal. So we can go from one form to another form based on whatever our computational needs are. Okay? Now, so we're going to first look at converting a fraction to a decimal. In order to convert a fraction to a decimal, we need to divide the numerator in that fraction by the denominator, and the result, or that quotient, is going to be in decimal form. So for example, 5 over 10, if I divide 5 by 10, my answer will be 0.5. So we have a decimal. All right? Now I can take that 0.5, which is in decimal form, and convert it to a percentage. You do that by moving the decimal 2 places to the right of the decimal point and add the percent sign. So in my example here, I have 0.5, which is 5/10. I move that decimal in front of the 5 2 places to the right. So you see my little arrows under the 5, so that decimal was originally in front of the 5. I will have to add a 0 in order to move 2 places. So I move it to behind the 5, then behind the 0, and then where that decimal lands, that will become a percent sign. So 0.5 equals 50%. I can take that percentage and convert it back to a decimal by removing the percent sign and moving the decimal point 2 places to the left. And we're back to 0.5. Now I can convert a percentage to a fraction. So in order to convert a percentage to a fraction, we need to remove the percent sign and place the number in the numerator that we get when we remove the percent sign, and then put 100, the number 100, in the denominator. So, for example, if we had that 50% we were talking about, I will remove that percent sign. Now I have the number 50. That will be plugged into my numerator, and I will place the value of 100 in my denominator, and now we have a fraction. Now I can take that fraction to a percentage by dividing the numerator by the denominator and multiplying by 100. So I will divide 50 by 100, and then I'm going to add a percent sign. If you divide 50 by 100, you get 50, and then you add a percent sign. Therefore, we're back to 50%. Okay, now let's consider rates, ratios, and proportions. This is another interesting concept. Rates, ratios, and proportions are kind of synonymous a little bit. They're different ways of expressing relationships between values. With a rate, if we're looking at rates, which are usually expressed or written as a percentage, it describes a measure, a quantity, or frequency that's going to be measured against some other quantity or measure. All right? Your book gives a couple of examples here. For example, the rate of speed, if I say 30 miles per hour, all right? That is an example of a rate. Or you can be looking at a unit of something, as in 50 cents a pound. Right? Or you can look at something like a birth rate, 20 births per every 100. Or interest rates. These are all rates. Okay? Now, when you're looking at a ratio is a relationship between things or one number to another number. All right? It's also a rate or a proportion. Like I said, these are just different ways to express a relationship between values. Ratios are usually written or expressed as a fraction. For example, 8 out of 10 or 8 over 10. If you wanted to convert a ratio to a percentage, you would do it the same way as if it was a fraction to a percentage, as we've already previously discussed. Now you can also express a ratio in the form of 8:10, which still means 8 to 10. So we can do it as a fraction, or we can express it in the form of the number, a colon in the other number that we're trying to express the relationship. Okay, so that basically means if I say 8 to 10, 8 out of 10 of something. Okay, that's a ratio. Now when we're looking at a proportion is a ratio in which the elements in the numerator must also be included in the denominator. So for example, if we have 30 students in a classroom and 12 are boys and 18 are girls, we can express the proportion of girls in that classroom by 18 over 30. 18 girls out of 30 students as a whole. That's a proportion. Now, another couple of basic mathematical concepts that we need to understand is that of averaging and rounding. When we average a set of numbers or scores or values, in which we call a distribution, when you average, you get the sum of all the scores or values in that distribution and divide it by the number of scores or values in the distribution. And if you recall in an earlier chapter, we talked about using the variable n to express the number of scores or values in a distribution. Therefore, for example, you can take all the grades that you are making in this course. Say you want to get your final test average. You will take all your test grades, get the sum of all of them. Say if you have 4 test grades, you will add all 4 of your grades up and divide that by 4. So the n variable in your distribution for this example would be 4. Okay? That's how you get the average, just like you do your grades. Now, you can also do what we call rounding. A lot of times when we are looking at rounding data, we're basically getting an approximation on a total, and usually this is done when we're dealing with decimals. A lot of times, one of the more common ones you will see is for you to round to the nearest whole number, but you can round to different decimal places, just depending on what your needs are for that computation. But again, the common one is to round to the nearest whole number, and so that's what we're going to do here. When you are rounding, you are looking at the number that comes after the number you're interested in rounding to. And when you consider that number that comes after the number you're interested in rounding to, your decision is based on if that number is greater than 5 or less than 5. If the last digit after the number you're rounding to is greater than 5, then you will increase the number you're rounding to by 1. If the last digit after the number is less than 5, then the number you're rounding to will remain the same. So let's take a look at an example. Say you have the number 12.36, all right, or 12.3600. If I want to round this decimal to the nearest whole number, I want to consider the number 3 because 12 is the whole number. So 3 is the number we're going to consider. Now, is 3 greater than 5 or less than 5? 3 is less than 5. Therefore, the last digit of the number I want to round to will remain the same, which is the 2. So when I round 12.36 to the nearest whole number, my answer is 12. Now, if I change that number and just switch the 3 and the 6 around, and now I have 12.63, and I want to round that number to the nearest whole number, now I'm going to consider the 6 in order to determine what the nearest whole number is. Because 6 is greater than 5, when I round 12.63 to the nearest whole number, my answer is 13. These basic computations are important. They can be applied to many different functions that will occur in an HIM department. For example, we can use the computations we have considered to help us to determine labor costs, equipment purchases. We can use these computations to examine productivity and to determine staff levels. For example, we may want to look at how many FTEs and PTEs we need in our department. FTEs being full-time employees versus part-time employees. We may also want to look at, say, we have how many coders will we need in our department? Well, we're going to need to consider productivity. How many discharge records can a coder code in an 8-hour period or in a workday? How many records can they code in a work week? So we would need to make productivity computations to make sure we have enough employees or workers to cover the workload. We also use these type of computations to calculate storage space. Maybe we are still using paper records. We want to make sure that all tasks that are in the HIM department are able to be completed successfully. So we take these computations to determine and make decisions based on these computations. So we have applications, computational applications. This is going to conclude our presentation on Chapter 3, Mathematical Review.